Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEX topic, factoring a polynomial involving a GCF, or greatest common factor, and a difference of squares, univariate. So there's only going to be one variable here. In this case, v might be x, might be y, but there's only going to be one of them regardless. So we should be looking for a greatest common factor anytime we start any factoring, because if nothing else, it's going to give you a smaller problem to work with. But in this case, it's actually going to make it significantly easier because this is not currently a difference of squares because 20 and 45, neither of those are perfect squares anyway. So what I'm going to do is I'm going to try and pull out the greatest common factor, which in this case is 5. So I'm going to pull a 5 out, which leaves me with 4 minus 9v squared. And then inside my parentheses there, I now have a difference of squares because 4, 9, and v squared are all perfect squares, so everything in there is. This 5 is just going to kind of get brought along. So I want to find the perfect square roots there of my two numbers for my a squared and b squared. If you remember the formula of a squared minus b squared factors into a plus b times a minus b. So this is my a squared and b squared. So I need the square roots to find a and b. So the square root of 4 is 2. And the square root of 9v squared is 3v, just the square root of each one separately. So now that I know that, I'm just going to bring my greatest common factor down, and I'll have my two sets of parentheses. I know it's 2, 3v, 2, and 3v, one's addition, one's subtraction, and we're done.